So our bell ringer for this section, we see we have the angle theta. I'm sorry, it's an implied right angle. And then we see that we have the side lengths. This is a 3, 4, 5 triangle. When we do sine, sine is what? Opposite over hypotenuse, which means if theta is here, opposite is 4 over 5. So that's all I was looking for. Cosine. Jason over hypotenuse. Okay, my Jason.
3 over 5.
3 over 5. And tangent.
4 over 3.
Opposite over adjacent.
Okay, so that is just our beginning portion of this. Our next part, I'm going to clear the slide. If you'd like to write down the title, you probably already had enough time. So this is 4.2, trigonometric functions in the unit circle. So we have the unit circle. We've been working with this all week. On this slide, I'll let you know what I think you need to take. So the unit circle is a circle with a radius 1. I feel like you probably already know that. We have focused on that. It is centered at the origin. So actually I had a question earlier about what are these angles, not angles, what are the coordinate points here? Well, this is 0, 0. You're moving 1 in the x direction. So this is going to be 1, 0. Here, you're moving 0 in the x direction, but 1 up. So that's going to be 0, 1. And you see that all the way around. Then the equation for a circle, this is just a nice reminder, x squared plus y squared equals r squared. And that's just a nice picture that goes along with it. So this next slide is not anything that we haven't had, but again, so in the unit circle, the radian measure of the central arc angle or central angle is equal to the length of the intercepted arc. Both of these are given by the real number t, and then on mine, I showed how that happened. I did our formula. So do you guys remember what that was? Let me erase it. So what was the formula for S?
S equals R times theta.
Theta, yep. And then here, in this picture, when we're looking at it, we see that this is, our angle here is represented by t. And so they switched that to, oh man, Jenkins, we have a radius of 1 and t. So we see here we have 1, S equals t. Because the radius is 1 based on the fact that it is the unit circle. That's all I wrote down on mine. Okay, so this is your trig functions, the 6 of them, and then their abbreviations. You guys have seen this. This is introduced 7th grade. So you have sine, cosine, tangent, and then obviously cosecant, secant, and cotangent are probably a little newer for you guys, probably geometry. But sine, cosine, tangent, you guys probably were introduced back then. And then these are your symbols that go with them. Again, you can take them if you'd like. If you don't remember them, when I go to use them, I expect you to know what we're doing. So for this to make sense, I'm going to draw the unit circle. So I'm just going to do a quick little, maybe not the whole thing, I'll just do a little picture, and that will allow you to see what they're looking at when they're making these claims. So if you want to start writing them while I draw this and you can add it, that would be great. Okay. Okay, so I'm going to let you write those down, and then when you're done with that, put this picture on your page. I'm sorry? I just couldn't hear you.
What is it say?
We can't read that.
Oh, is it too small?
Yeah.
Okay. Okay. So I'll try it again. Yeah, it's like a all or nothing.
Oh, nothing kind of good.
Yeah, like it won't let me erase that small. So it's not going to be proportionate. Is that okay if I leave it? You know I don't want it.
Yeah, it's fine.
That's not perfect.
There we go. Is that going to be bigger? You can't see it until I let go. That's neat. Okay. So let's try this one more time. Nope. Okay, and then you're drawing a triangle in yours. I'll go over them if you can't see what they are labeled. Is it just because the purple's so faint? Or is it just because it's too small?
It was just too small.
Okay.
It was just too small.
Thanks, guys. Okay, so we're here. And you see that we have, now with the unit circle, you're looking at the degree, theta. And then here we're representing it with t, right? We just showed that in the last slide. And then we know that our hypotenuse is 1. So sine is opposite over hypotenuse, which is y over 1, which is why they left it as y. Cosine is adjacent over hypotenuse, which is going to be x over 1. So they're actually just plugging these values in to get what you see listed to its left. So those numbers are coming based on the fact that you're moving an x distance and a y distance that we're labeling xy, and then you have that angle t. So we're here. We have to find these trig values. Would you like a second to draw your picture and write them before we get started?
Yeah.
Okay, so I'm going to give you about 40. We saw on the last slide that sine is what? Is y. Which means here, my y coordinate is 1/2. Now we have cosine, which was what? Which means that my x value is perfect. And then we have tangent. And what's tangent? Y over x, which is equal to 1/2 over the square root of 3 over 2, which is the same thing as 1/2 over. We have to rationalize. I'll do one more step. Oh, come on, pen. So you get the square root of 3 over 3.
That negative 1 over root 3.
Where you at? It's an equal sign that just ran close together. Do we have any questions on how we arrived at these? All of this comes from the fact, yes, Jordan? Okay. So on the last slide, we learned how these were defined on the unit circle, so that you saw that sine was going to be your y coordinate. So we came over here to our y coordinate, and in order to pair your y coordinate is the second one. So whatever it is, it's going to go in for sine. And then the same thing happened for cosine. Cosine is always going to be your x coordinate. Underneath that, we see that tangent was defined on the last page as y over x. So we took our y value and then divided it by our x value. After rationalizing and getting that square root of 3 out of the denominator, blah, 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 we were able to arrive at square root of 3 over 3. Does that help? Okay, I have another slide of these, and normally I was going to go to it, but since we actually have space here, I'm going to try to do it to the side. So I'm going to change my color. We're going to now write in blue, and I'm going to put these on here. So our next one is cosecant of t. We also have secant of t. And we have cotangent. Cotangent won't need, yeah, we'll make it work. Cotan t. Okay, so how do we define cosecant? 1 over y. Or I wrote on my page 1 over sine. So 1 over y, which is 1 over 1/2, which we know is 2, right?
2.
Okay, we have secant. How did we define that? 1 over x, which is 1 over the square root of 3 over 2. Same thing as 2 over the square root of 3. We got to rationalize. We end up with 2 square root of 3 over 3. And then last but not least, what do we have for tangent or cotangent? X over y. X was what? Divided by 1/2. I'm gonna change color so I don't write into everything else. So here we are going to rewrite this. I'm gonna go down so I have some space. I have 2. Nope. Try that one more time. I have square root of 3 over 2 times 2 over 1. Because remember, when you're dividing by a fraction, it's like multiplying by the reciprocal. You cancel, and you get the square root of 3. Okay, do we have any questions to this point? I have one thing that I want you guys to add. When we're doing this, to help you remember that, on your unit circle, I know you don't currently have one, I always write CS. Okay? So cosine sine. CS. So when I went here, I had Miss Evans, and there's a kid in our class trying to remember this, and because we have to memorize all this eventually, and she said, what can we come up with to memorize CS, to remember that goes in that order? I'm giving you all the stuff to memorize, right? And his name was Corey Simpson, and that's literally how I remember this, Corey Simpson. And then as I taught it, all my kids are like, chicken strips, Caesar salad. So pick something CS to remember the order that you have it in. If you just naturally memorize that, that's fantastic.
I just like how cosine
But
sine sounds.
I would like you to find something to memorize it with. Okay, so we are at the domain of the sine and cosine functions. So you know the domain, we've seen the wave, is negative infinity to positive infinity. And you have seen the range. It goes up to 1 and then goes down. So it oscillates between those two. Both of those functions do that. So I would write down the domain and range. So right here, what I highlight is what I would have on my page. Domain, sine, cosine, negative infinity, positive infinity. Range, negative 1 to 1. Okay, so for our next example, I'm just going to write example. I don't know which number we're actually on. Example 2. Thanks. We are given our circle. And oh, nope, don't like that. We're going to draw. Nope, still hate it. Okay. No, that's not nice. Okay, and then our question is going to center around pi over 4. What is pi over 4? It's 45, right? So that's where we are going to focus on. I'm going to try to make this bolder so you guys can see it. And we see, ooh, that's too bold. Okay, so we see we have our triangle here. I'm going to draw in a little arrow to let you know that's going to be pi over 4. And we have discovered this yesterday. This is going to be what? I left it up on the board, so I guess there's no point in me actually quizzing you on it. Square root of 2 over 2, square root of 2 over 2. Okay. Oh, you can't see it. Would you like me to draw it again below? I'm sorry. I was super excited about that. Give me 1 second. So now that we've moved the picture, brought it down, you see that our angle is pi over 4, which we know is 45 degrees. And yesterday we discovered using special right triangles, the coordinate points for those would be square root of 2 over 2, square root of 2 over 2. So I would like us to go through and do all of our trig functions. So we have sine. What's their sine of pi over 4? We have cosine of pi over 4. Is that too high? No, okay. Tangent of pi over 4. Do you want to start there and then we'll go on to the next one? Do you want us to do all of them right at once?
We might as well do them all, right?
Okay. Okay, and I'm going to put cotangent off to the side. Okay, so we know sine, right? Chicken strips. So which one is it going to be? Doesn't matter in this one, right?
I like
Yep.
it.
Cosine. It's our x coordinate. So that is, again. And tangent is what? It's going to be 1, right? You're putting x over y or y over x for both of the cotangent and cotangent. You know it's the same thing, so they're both going to equal 1. I can show that step in this one and you understand it for the next one. So we have square root of 2 over 2 divided by square root of 2 over 2, which equals 1. Now you are at finding our reciprocals. So we know, well, you guys actually had these already given to you. So what is cosecant? What is it? 1 over y? Which we know is 1 over square root of 2 over 2. which gives us 2 over the square root of 2. We rationalize. We end up with 2 square root of 2 over 2. Cancel our 2's. What am I left with? Yep, just root 2. And you see a very similar setup in our last one. We have 1 over x, right? We don't have to show all that work because I already did it since it's the same 2. And we end up with just square root of 2. Okay. About even and odd functions. Don't know how much of that you guys remember. It's been a few chapters. So for this, we see that cosine and secant are even. Everything else is odd. So when we say that it is even, notice that our degree is negative. So negative t, it loses its negative sign. Here, when we have a negative and the odd, the negative comes out front and multiplies. So notice that difference. I would write these down. I expect you to know them. Okay, so again, we see these are even. So cosine and secant. And remember that secant is 1 over cosine. So that makes sense. They go together. And then we have sine and tangent. And then that's their reciprocals, which are going to be odd. Notice how they change. Our 2 examples are secant, negative pi over 4. So when we do secant, was it even or odd?
Even.
It was even. So what does that mean? It's the same thing as secant of pi over 4. What is secant over pi over 4? We just did it. You can look back so we don't have to do all the math, or we can redo the math. Just the square root of 2. But here we see that sine is odd, right? So the negative comes out front, and we end up with the same thing as sine of pi over 4. So what was pi over 4?
45.
It's 45 degrees, sorry. What is sine of pi over 4? Root 2 over 2. And then because it has the negative up front, we multiply it here, and it becomes a negative square root of 2 over 2. So those are the 2 here for the examples that go with even and odd. Our next page is about writing out those identities again. Now have our reciprocal identities. You guys probably remember most of these. So you don't remember any of these? Okay, so when we get that piece of paper tomorrow, I'll have you guys add these. So sine is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. And then you see the same thing is true. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. And then we have tangent, which is sine over cosine. And we have cotangent, which is cosine over sine. I don't know if that was ever a concern for you guys memorizing sine and, or not sine, tangent and cotangent. Sometimes I flip those. So I remember it as tisk. So T-S-K-C, but the same sounds, right? Tisk. So T sine cosine. I don't know if that helps anybody, but. Okay, and this is our homework for tonight.